Bend a paperclip back and forth. It stays bent, it doesn't shatter. And catch a spoon at the right angle, and it throws your face back at you like a mirror. That bending, that shine, and the way a metal wire carries electricity all come from one idea: the way metal atoms hold themselves together. Let's meet it 4 times, each time a little deeper. First, the big idea. Metals behave strangely. Push on most solids and they snap. Push on a metal and it bends. Most solids don't conduct electricity. Metals do. And metals shine. One kind of bond has to explain all 3. Here's the trick. A metal atom holds its outermost electrons very loosely, so it just lets them go. Do that with billions of atoms at once, and their loose electrons pool together into one shared sea that washes through the whole piece of metal. What's left behind is a grid of positive ion cores sitting in that sea of negative electrons. The attraction between the two, the cores and the shared electrons gluing them in place, is the metallic bond. Now, how it really works? Picture the cores locked in a regular lattice, each one positive, all bathed in the same electron sea. Those electrons are delocalized. They belong to no single atom, and they're free to roam across the entire metal. That's why metals conduct. Connect a battery, and the whole sea drifts toward the positive end. Current almost instantly. And notice, it's the electrons that move, not the cores. That's also why a solid metal conducts, while solid salt only conducts once it's melted. And because the sea holds the cores from every direction at once, the bond isn't fussy about angle. Strike the metal and the layers of cores just slide past each other, the sea flowing to keep up, so metals bend and dent where a crystal would crack. Finally, let's go deeper. Bring a few atoms together, and their electron energy levels split. Bring a trillion together, and those levels blur into continuous bands. In a metal, the top band is only partly full, so there are empty states sitting just above the filled ones, and it takes almost no energy to nudge an electron into them. That partly filled band is what makes a conductor. At the deepest level, we can drop the cores almost entirely and treat those electrons as a free gas filling the metal. That one picture pays off everywhere. The gas carries current, it lets the layers slide, and it soaks up incoming light and throws it straight back, which is exactly why polished metal shines. From a bent paperclip to a free electron gas, one bond understood at 4 depths. And that completes the trilogy. Ionic bonds transfer electrons, covalent bonds share them, metallic bonds pool them. A lattice, a pair, and a sea, 3 ways to hold the world together.